as I've worked on different projects, I've had the ongoing challenge of how do I interconnect different components of whatever project I'm working on. Maybe it's my 386 build or a 486 build or something previous to that, my 6502, 65816, or different video cards that I've built. And I guess throughout all those projects, some of the common ways I've interconnected different PCBs would be things like simple pin headers. And I've used that to use ribbon cables to interconnect. I've used that as a way to stack a daughter card onto some type of a baseboard or a base card. And that's been fine. Seems to work well and be fairly robust. On a lot of my systems, I've used a 16-bit ISA slot, even when I wasn't following the ISA spec, but just simply as a way to connect and route signals through that. More recently, I've been following more of the ISA spec for my 286, 386, and 486 builds. I've also used the PCI physical connector to transfer signals between maybe a backplane and some type of a daughter card. And the same, I've used PCI Express, the X4 connector, on one of my debug projects. These have worked well. One of the things that these here don't really, maybe at least the ISA slot, the PCI slot, and PCI Express slot, they're not really well suited if I want to lay two PCBs down side by side and connect them. And for that, I would either go to a right angle pin header, or I've more recently experimented with these Eurodin connectors instead. And so on one of my 386 builds, I had a set. So two of these connectors on one board and the opposite two as far as gender of the connectors on another board. And then I clicked the boards together to give me one large 386 board. And those connectors honestly have worked well. I've run pretty good clock speeds through them. They've handled it well. They're a nice connector. They physically snap together nicely, and I guess the word I would just use is it's just a robust connector. Now, all of these I'm sure have pros and cons, and if I would call out my quick pros and cons on some of these, when I look at the pin headers and the ISA PCI slots, they're inexpensive, and the ISA slot and pin headers have been pretty robust. I think PCI isn't quite as robust as the ISA slots. And then when I got to PCI Express, like the X4 connector, I just found that wasn't enough of a connector to really maintain a nice, solid, robust connection. The Eurodins are great as far as the connection is concerned, but they're expensive. So I can do a 2x20 pin header for 25 cents. And the ISA slots, I had sourced quite a few of those at about 29 cents. PCI Express was maybe more around this 87, or PCI was 87 cents. PCI Express was probably something comparable to that. But these Eurodins were expensive. They're $5 a pair. So if I want to get the male and the female, that pair is $5. So if I have two sets of those on a system, that's $20 just in those four connectors, which for me is not something I want to be spending on a project that I'm working on. A lot of my projects are pretty temporary, and I move on and kind of keep building new things as I go pretty quickly. So I get a little heartburn spending $20 on connectors, whereas I could put in 10 ISA slots for $3 instead of the $20 for two sets of the Eurodins. So I haven't had any concerns with the ISA slots up to this point. Just a side note, I did notice that the price of those slots from the same vendor I've been getting them went up from 29 cents to 86 cents. So they have gone up quite a bit in price, basically tripled in price. And I don't know if they're maybe just starting to run lower on stock or what's going on there, but I notice those are moving upwards. But all of these have pros and cons. I've been looking for, can I find some next generation of connector that I might try to use that isn't extremely expensive. As I get into higher density, so on my 486 and 386 builds, I've got 32 address bits, 32 data bits, a lot of control lines, and I just need a lot of connections if I want to add adding cards, or if I want to have a side-by-side, set of cards that snap together somehow. I've also maybe applied this logic to power connectors. The power connectors I've been using really aren't that expensive, maybe on the 20 to 30 cents per connector type of thing. But I've been trying to keep an eye out for a more affordable version of power connectors as I go too. What I have recently ordered up and received in is these connectors here. So you're probably going to see me experiment with these in upcoming projects, and if they work out, I'll probably use them quite a bit because I have quite a few of them. And I'll talk about the cost of these, at least for what I picked up, what the cost was for these. So these first two connectors on the left are part of Molex. They have, I'm sure it stands for something, but EBBI connectors. And these connectors that I'm going to use are a 68 pin. And you can see here's some information from Molex's website. But essentially on the left, what you're going to see as far as connectors is that there is what they're calling a receptacle. And then the connector to the right of that, they're calling a plug. So those two together basically will connect up. And it's a very solid connection. This is a really nice connector as far as connecting two PCBs together. And the ones I have are 68 pin. So in a pretty small footprint, this is quite a bit smaller than that EuroDIN. EuroDIN was 3 times 32, so that was a 96 pin. This is only a 68 pin, but it's quite a bit smaller, which pros and cons to that. That also makes some of the routing here a little bit trickier, which I'm going to talk about. But the nice thing about these connectors is I managed to pick them up for 35 cents for the pair. So I've got both the receptacle and the plug, and together that cost me 35 cents. And I've got a whole stack of these, so I can use these for a long time. Then this little connector to the right, I believe it's called a Saber connector. At least that's what's on the drawings that I'm looking at. So it's a Molex Saber connector. It's just a 2-pin, and I think I'm going to use it for power on a lot of my little projects. Just an inexpensive, I can solder this on the boards, and I'm not spending a lot of money on a fancy connector, and yet it is a pretty nice connector for maybe connecting it up to my power supply as a 2-pin power supply. But as I got into this, one of the challenges is I want to continue to use EasyEDA as my design tool. But interestingly, in EasyEDA, these connectors I want to use aren't in the library. Someone hasn't already created the footprints and such for these for me to use. And that's what I was going to spend a little time in this video, is just talk through setting up EasyEDA to support these new connectors that I'm going to start leveraging. And maybe what I'll do is jump over to EasyEDA and show this for a second. So if I jump over here, and I'm going to just close some of these tabs and I'll come back to them in a second. Here is a PCB that I put together, and in this case, maybe I will reopen the 2D version of this. On the left here, I'm using one of those EBBI connectors, and this would be the receptacle. So I've got the receptacle, I've got a footprint for it. It should click into here, and it solders down, and it's got some positioning pins that it uses. Over to the right is the paired up, the plug that goes with that. And I'm just using a simple little 100 by 100 millimeter board just as a test board, basically. Can I get this set up correctly so that I can put in that connector, and on the right put in the other connector, maybe populate a few of these boards, and can I click them all together and follow that signal through, or use that to do some testing. And then I also have this up here, which would be that power connector, or that 2-pin Saber connector that I'm going to use for power. But when I went into EasyEDA and I went over here to the library and I searched and I tried to find these connectors, I was not having any luck. I found a partially completed vertical connector. These are actually the right angle connectors. There's also a vertical version. So someone had started that, but they didn't do the physical side of it. It was just kind of the logical schematic piece of it, or the symbol, I guess. But that wasn't going to get done what I needed to get done. So I wanted to be able to come in here and just drag out a component in the schematic like this. So here's the schematic for that PCB. And you can see here I have a single component here, and it is using a footprint. And that footprint is an EBBI 68 receptacle. And if I come down, you're going to see that I also have the plug. So I have created these, and when I add those and then I go over to the PCB, they come up. Here's a single component, and then over here, here's a single component. So, I can just add one of these, drag it to wherever I need it on the board, and it's ready to use. And I can start, connecting things to it. In this case, I just connected some regular pin headers, and that's what you're seeing is all of these pins just run out to some larger pin headers that I can do some testing and debugging with. And same with this one over here. And I'm not too worried about how this is laid out. It's really not going to get used for much other than just some experimenting that I'm doing. The main experimentation is physically, does this all go into the PCB correctly, and can I get my signals routed through it okay? And can I take a couple of these boards and click them together and just verify that a pin here goes through to the next card to whatever its associated pin is. And maybe I can run some different speed clocks through it and see at what point do I have issues, things like that. Or maybe I might even cascade 5 of these together and just see what does the signal look like from where it started to the 5th board, especially considering I might have some jumper wires and things like that on this board. And then also the physical power connector, I want to make sure that goes in here okay, and I can apply power to it, and that all seems to work fine. And I might jumper the power with just a simple little pin header from board to board, just to see how well that works or doesn't work. And I've set this up as a 4-layer board, and I'm just going to do some testing. But maybe I'll show you what did it take to get these set up. I'll show you one other thing and I don't have this exactly dialed in yet, but it's enough to help me get through what I was trying to get through here. I did, when I created these components, pull in the 3D model, and for some reason it just comes through as all black, and I don't get the nice, like these pin headers have this nice, the shading and things, but I don't get that on these, and I wasn't going to dig too deep into it. But what I was able to do is to get them pulled in the 3D model so that I could validate, that this is what it's going to look like, essentially how they're going to fit onto a PCB. Now, let me show you what it takes to maybe go fetch a 3D model and suck this in and then start using it. The first thing that you probably want to do if you're going to try to set up your own, like if I come in here and I go to my library, and I can see that there's, the library from JLCPCB or this LCSC or what's considered system stuff, or I can come in and also look for things that maybe someone else has put together. So let's say I come in here and I'm looking for, let's just say a W65S816, W65C816. And so this is a chip, a processor. I want to use it. I click it. They have it in the system, which means I should be able to generally trust it, but I can see there's a typo here, and I do see that they've got the actual symbol, and then they've got the footprint, and that all looks pretty good. Or I can see that the community has contributed a bunch of different ones, so I could look through those and see that there's a DIP version and a PLCC version and whatever. And these you always got to be careful with, because sometimes they're good, and I found about 1 out of 10 you'll find a pretty big mistake in some of these, even to the point where they're not even usable. So you got to pay attention to any of these that are contributed by someone in the community. But I want to have my own show up in here. So if I come in here and I want to search for EBBI, for example, there's this one connector someone started, and I can see that they came in here and they've got the symbol, but then there's no footprint to go with it. So that's not going to do me a whole lot of good. But I can now go to my workspace and I can choose one or the other here. So I can choose the receptacle, I can choose the plug, and these are the ones that I built. And so if I wanted, for example, I could make a new test project for. And if I go to my library now and I take I want that receptacle, for example, I can just choose it and place it. And there's my receptacle. If I want the plug, again, I can just come in here and choose the plug, and I can place it. I can wire these up, and let's just say I'm going to directly wire those together like this just for the fun of it. I can save that, and then I can go ahead and make a PCB out of that. And so now here's the PCB that it is creating. So this is a single component. So this is my receptacle, and maybe I want to put that on the top of this. And the way I've got it set up is I just need to overlap these lines, and I know that's positioned on the edge of the PCB correctly. And then this other connector, same thing. This line here is the edge of the PCB. So now I've got something like that. And I can, from there, take it to a 2D and see what it looks like. And you can see here that part of this PCB is going to get cut out when I actually go to have this ordered. And that's so that it fits this, this receptacle correctly. And if I go to a 3D view here, now I can see what that's going to look like. And I can start, routing, connecting up this connector over here. And I'm good to go. And so that's pretty easy as I want to use these components moving forward. Now, I can also do the same thing with that power connector. And so I might come back and say, well, I want to add a power connector, and I go to my library, and I can do this a few different ways. I could go search for Sabre, and maybe there are some community ones, and I didn't look for this community one, but maybe here's this looks like pretty close to the one that I use. So, I could add in this community Sabre connector, and let's see, on this, the outside should look like this. Now, I might want to also go in and add in from the library my own Sabre connector that I created. And so I can place that, and that should be, pretty much the same thing here. Now I did take mine off of the spec as far as hole size, so I can see the one from the community, they used a little bit more of an oval. I don't think that is what was in the spec or in the data sheet, but I'll go ahead and put this in here, and I'll save that, and then maybe I'll just take a look at what the 3D looks like for that. So this one didn't have a 3D, well, actually it did. It has a really nice 3D part to it. So, I might use that connector instead since that's there. Now these two I couldn't find, and I need to figure out how to get it to look nice like this and not this generic block like that. So that's something that as I go through this, if any of you have ideas, let me know. But I'll walk through that process real quick. How did I create these and get that into here so that I can start modeling that up? So I think what I'll do is just kind of show you the process. So I might start with, maybe I'll pick one of these connectors and say I was going to start from scratch on it. So this connector here, this is the part number. And I can actually go out to Mauser, and Mauser has a lot of these 3D libraries basically for these components. And if you go through Mauser, they have you load up a little app to make it a little bit easier, but that little app is a library loader. But when you say find me a component, it just takes you to this web page, and I'm going to search, and then as I search, it comes back and says, okay, I've got a couple of different components for you. And the first one I used was this one up here, and it shows me what that looks like. And I see that there's another one. I haven't tried this one, so maybe I'll do this one right now and see if this comes through a little bit differently. But what I can do is I can say I want to go ahead and download that 3D. I download it. It doesn't cost anything. And it has, on my other screen, popped up this. It says, okay, this is a 3D model only, and it's been extracted to, this folder on my hard drive. And so what I'm going to do is just real quick take a look. And what it downloaded was a single file, which is an STP file. So if I take a look at this, it's this right here. So it's an STP file. Now, if I want to use that in EasyEDA, I can't just directly use it. EasyEDA does not support that STP file. So what I'm going to actually do is open up another piece of software, and I just went out and grabbed FreeCAD. And so this is loading up on my other screen, and I'll drag it over here as soon as it pulls up. Okay, here we go. And what I can do is tell it that I want to open, and I'll go open up that file. And so here is that file that it opened up, and I can see that nice 3D rendering of that component. And what I'm going to do is I'm going to export it, and I just need to choose the object, and I'll say export. And in the type here, what I'm going to choose is an alias mesh or OBJ file here, and I'll give it a name, and I'm just going to use the part number, and I'm going to call this ver2 since I had used that other one previously. This will just help me separate them as I'm looking at them. And then what I'm going to do is come over here, and what I should find is that there is this file I just created. For EasyEDA to use this OBJ file, I need to have it be zipped up. So I'm going to compress it. I don't know why I need to have it compressed, but it's a requirement on the EasyEDA side. But now I can come over to EasyEDA, and I can make a new 3D model. So I'm just doing a file new 3D model, and I can add in that file that I was just looking at. And so here's that zip file, and I choose to open it, and it should show me that it found it, and I hit save. So I now have a 3D model in EasyEDA for that component, and maybe this one will come through better than that other one did. Okay, so that's saved. I can get out of this. Now what I'm going to do is I'm going to create a new footprint. And so what I would want to do is basically lay out my footprint. So lay out all the connections. So let's say I've got a series of pads that I'm going to have to lay out, in whatever orientation that matches what's in the data sheet. So I can go over to, that was the plug that I have, and I can read through the data sheet, and it'll tell me the distance between the pins. Like right here, it's a 1.27 millimeter. Shows me the distance here is a 1.905 millimeter between basically these rows. And I can just really read through this data sheet, and it tells me how all of this should be laid out. Now, what I've already done in this version is I've laid out, what you saw previously, but now I'm going to change the footprint to that brand new, or the 3D model to the one that I had just brought in previously. So I've got a version 2. And here I can start to see it doesn't color it any better. So what I was hoping to see, it's got to be sized here, and their auto kind of works, but you can also see that it doesn't have it set up in the right orientation. So that's where I have to mess with the rotations and get this set up correctly on the PCB. But I don't see anything better here than the plain black mess that I had before. So what I'm going to do is just cancel that, and I'm going to just use the footer. I'll just back up here. I'm going to close that just to save some time here. I'm going to go to footprint, and I'm going to edit not the version 2 one, just the first one, this one right here. And I'll use that first 3D model I was using. But what I had done here is I just went in and I laid out all of these in a setup that matches what's in the data sheet. And the data sheet also tells me, how large should these holes be, basically to these pads, basically. So if I look at this, it tells me the pad should be 0.8 millimeter. And then I'm interpreting this as it should have a 0.13 of copper on the outside of that. And that's essentially what I've set up. So I can look at this and see that it's a 0.8 millimeter for the hole. And if I add a 0.13 to each side, that gives me my 0.862 for the overall. And so I've got that. I've got these set up on a grid. You can see what I did for the grid size, the snap size, the tighter snap, if I want to use that. And then I laid out, this hole right here that the actual connector will use this little, it's got a pair of pins that basically are used to just kind of position it correctly. And so what I'm doing here is I'm editing the footprint part of this. And if I do go back in, I can also pull up the 3D model, and I can kind of take a look at, how does that 3D model sit on top of the PCB. And I had to adjust this. It didn't have it right when I first pulled it up, and this up here doesn't show up quite right anyways. But I ignore that, and I'm really looking at what's down here below. And you can come up here and drag this around so you can try to get it positioned right. You can set the width or height manually and just kind of get it so that it fits the PCB, because I know the PCB is correct because I'm going off of that data sheet. And so I'm really just resizing the 3D model to fit the PCB. And that way later, when I go to put it on a larger PCB and see what it looks like, I can kind of validate that it looks like it's coming together correctly. So you come in and you do a file, you do a new, you make your footprint, you lay out the connections and any holes, anything else for the footprint, give it any text. I also put in a cutout here so that I know that has to go up to the edge of the PCB, and this is the line that's just going to match the cutout of the PCB. If for some reason this was in the middle of the PCB, it would cut a line in the PCB, but I'm just using that to reference where the edge of the PCB is supposed to be. And that again goes back to the data sheet that shows me that distance to say, well, from this pin for positioning down to the edge of the PCB should be 6.6. And you can use the measuring tools in here and validate that I've got 6.6 there. But I don't have those on here anymore. Now, once that's done, then you can turn around and do a new symbol. And in my case, I'm just going to edit a symbol for the sake of time. So if I go into the library and I go to symbols, and I'm looking at just the symbols I have, I can pull up the symbol for this would be the plug again that I'm working on. And this is what the symbol looks like. So I just basically said, create a bunch of pins, and I numbered them 1 through 68, put on some text, put a box in there, and called it good. Now here I do need to tell it what footprint to use, and then when I choose a footprint, I can line up all my pin numbers, just validate that whatever pin 1 is on here matches pin 1 in my footprint, and etc. But then that should be now the symbol that I can use that leverages the footprint, that leverages the 3D model. So if I go in reverse order here, I'm taking symbol to footprint to 3D model. When I created this, I first brought in the 3D model, then I made the footprint, tied it to the model, then I created a symbol and tied it to the footprint. But then at that point, when I go to library and I look at my library, that just shows up as a plug that I can use whenever I want to use it. And so then I can go back to this sheet where I'm just doing testing, and I can just say I want to add another one of those plugs. I can place a couple of them, and of course wire these up however they need to be. And then when I go in and I update my PCB, I'll see that I now have 2 more of those that I can leverage. And so I'm going through this kind of fast, but here are 2 more of those. And so I can, kind of get these lined up where I want them. Okay, so let's just say that's where I want them. I can then go check out the 2D view, and I can just validate, that everything looks like it's where it should be. And then of course I can flip to the 3D view and kind of get a better feel for what this PCB is going to look like. Now, one of the challenges, like I mentioned before, I can't quite figure out why EasyEDA brings this in as just solid black, and you really don't get any 3D perspective with it. It seems like if I open up that OBJ file separately, let me see if I can do that here quickly. So here I just opened up that other OBJ that I had just brought in this 3D viewer tool. I think this is just part of Windows. You can see that it seems to have, I can see all of the, I guess, the shadows and the perspective I'm looking for. For some reason, when I bring it into EasyEDA, I'm not getting that. So I'll have to research why that is. I'm sure it's user error on my part. There's something I'm not doing right. Or maybe it's a limitation, something with EasyEDA and how I'm trying to import the file. But I would expect something a little bit better than just these black. I can tell it's 3D, but I just doesn't look like what I would ultimately hope it looks like. But if I go through maybe some of these other, like this other library, I probably will actually go back to, let me just do this for a second. If I go back to projects, and I had this one down here where I was using my own power connector. So down here, that Saber 2-pin, I did the same process. So I went in and I downloaded the 3D model for the power connector, which would be this here. And it just came in as a kind of a 3D blob basically for the power connector. But then I, from that, created a footprint for it, and that would be this Saber 2-pin. So there's my footprint. If I want to preview, the 3D of how it's starting to come together, I can look at that. Then I created a symbol for it. And so there's the symbol I built, just a box with 2 pins, and I put the little labels. This is what it's going to look like on the raw PCB. And now I can just place that wherever I want to place it. And when I then turn around and go to the PCB, this is one component right here, just like this was one component and this was one component over here. But I have one for that power connector. And then from the power connector, if I want to see it in the 2D view, that's what it looks like. And if I want to go back to the 3D view, then I'm going to get the 3D rendered version, which again came through as this black solid instead of that other one that I saw that looked much nicer. But this one has the underlying set up the way I want it. I also noticed on this one that the 3D that I pulled down actually it was wrong. So it was expecting these positioning pins. Basically, here's the ones I soldered for pin 1 VCC and pin 2 ground. But it was actually wrong in the 3D model. So I went off the spec, and I'll show you what I did to validate that this was right at the end of the day. But the 3D model I grabbed from Mauser was wrong, which was interesting. Maybe it's user error again, but I pulled it in, and it seems to be off as far as I can tell. When I got all done with all of this, maybe how did I validate? Just to pull this up real quick. If I step forward, this was a printout. So I just printed out that PCB that I was just looking at on paper, and that's why it kind of looks the way it does. This is just a picture of that printed out PCB on paper. And then I actually took the real components and went and positioned them and just made sure everything lined up, and it all looked really good. So I think that PCB that you see on this printout, or if I go back over to here, this PCB I think is pretty close with those custom components on it. So I've got my power one, and then I've got the EBBI receptacle, and I've got the plug. And again, I think what I'll do is I'll order up a batch of these PCBs. They're $2 or whatever they are. I did do 4-layer, and I do have an inner VCC and an inner ground. And if I go back to the schematic for this just for maybe a second, just to show you a little more detail, what I did is I'm just running everything out to a pin header, except for I've got 8 grounds. So on the receptacle, I have 8 lines going to ground. On those breakouts, the same lines are going to ground. And this would be a mistake, so I don't know what happened there, but I will fix that. And then for the plug, same thing. I got 8 lines that are set up for ground. So I'm running a whole bunch of potentially signals through this. I've got a bunch of grounds that I can work with and see if, for example, if I test high speed on this R2 right side of ground versus R7 that isn't as close to a ground, will I see a difference or not? That's some of the testing I want to do. But I've got my receptacle, I've got my plug, I've got this Sabre 2-position power connector that I'm going to use. And that then, what I should now do is go to, I'm going to show you, I'm going to update this real quick. For some reason, I was missing that ground connection, and I'm betting that would have been any of these on this receptacle. So pin 1 on the receptacle. Yeah, it's going over here. So it's got those 8 connected, but they never got to ground because it was missing the connection to ground. Okay, so I connected this ground correctly. I've come back in here. I've gone in and done a global delete. I deleted all the tracks. Just to verify, I've got 4 layers of copper. I have these set to plain. If I edit my VCC, I can validate it's tied to the net label VCC, so that all looks good. I've exported this for routing, and I have jumped over here to free routing. I've done the routing, and now I'm going to go ahead and save the results of that and come back over here and import that. And so at this point, that all looks good. I just want to double check that like pins here, these pins are grounded properly. That does show it's tied to all the other grounds, and I can see it's tied to the inner ground plane. So I am going to go ahead and rebuild all my copper. Shouldn't be necessary, but it seems like I run into issues if I don't do that. And then I'm going to go over to my design manager, just make sure I have no DRC errors, and that came up clean. So at this point, this is now the updated PCB that has that extra ground connection made that was missing before. And if I want to go back to the 3D view, I can do that by going here. So this is updated and should be good to go. And I think this is probably what I'm going to order up here just as an inexpensive little test board. Again, if I want to go in and just take a look at fabrication, $23, of which it's going to end up being 20 of that is probably shipping. So let me just pull up this web page and see what it looks like. Oh, very interesting. I'm going to have to tweak this component because it's sticking out past the 100 by 100. You can do like 101, 102 millimeter by the same, and you won't have an engineering fee. But if you go above the just slightly over 100, like in this case 112, and it's because this thing is sticking out that I'm getting to that. So that's interesting. I don't want to pay a $24 engineering fee. I think I can just tweak this component quickly here. So I'm going to do that. I'm going to close out of this. I'm going to go back and let me see. I'm just going to get all this junk out of here real quick. Okay, so I'm going to go to my library. I'm going to go to footprint. And it is the receptacle that is got that sticking out. And so I've got this cut out, and really I had put all this in just sticking out. I really don't need that because this is the cutout, this is the edge of the board. So really I can delete. I'm going to see if it'll just let me get rid of all of that and call it good. So that is updated now only to go to here and not all the way down here. And let's just see what that does for me here. So I'm going to go back to my library. I'm going to go to my symbol. I'm going to grab that receptacle, I'm going to edit it, and I'm going to update the footprint by just reselecting it. And so here's my receptacle. Okay, that is updated. Now I'm going to go into this little test project I've got, and I'm going to update the receptacle from the library. And I'm going to save that. And before I bring it in over here, I'm going to go ahead and delete all my tracks. And I am also going to change these to signals because it's faster if I do this. And then I will go ahead and do a update of my PCB. So it's going to replace that with the new one. I'm going to save that. And I'm going to go see what the 2D version looks like. Looks the same. I'm going to look at the 3D version. We got the plug sticking out. Let's just see if that was enough, though, that when I go to fabricate, which is, this is not routed, so I know that. I've got to reroute it yet. But I want to see if it gets rid of it thinking that it's too big of a board. Okay, so that cut it down correctly. So now I'm down to a $2 board. Okay, so let me, yeah, that's all looking the way I would expect it to look. So it's a $7 board. And if I go with the cheap shipping, it's like $2. So for, $9, I can get 5 of these boards. So this ended up being a fairly long video. That's where I'm going to stop. But just kind of as a quick recap, if I go back, I'm trying to leverage some new connectors that really are inexpensive for me to use and should be nice quality connectors. As part of that, I wanted to set up my library in EasyEDA so that I could use either the receptacle or the plug or this 2-pin power connector. And so to do that, I went through and brought in the 3D models, and these were just the ones that I downloaded from Mauser. Now in this case, this one I'm going to delete since it was not any better than what I had already. And this one, I don't know why it was there twice, but I'm going to do the same. But I brought in those 3 3D models. So one of them was, for this power connector or 2-pin connector that I'm going to use for power. One of them is for this receptacle and one is for the plug. Basically these, this is the receptacle here, this is the plug here. But I brought in the 3D models. I created the appropriate footprints. So I've got the receptacle footprint, again, the model to go with that and kind of see what that looks like. Same thing for the plug, which is this one here. I'm going to go delete this one just because I don't need it at this point. Delete. So I've got my plug, I've got the receptacle, and those are coming together just fine. I've got this 2-pin connector, and I can see what it looks like. Then I turned around and created this symbol that leveraged those footprints. So now I have a symbol for the receptacle. Again, here's the nice symbol that I work with in my schematic editor. Here's what I'm going to see when I start laying out the PCB. Same thing for the plug and for the power connector. And then as I laid all of those out, I basically created a schematic that looks like this. So I took the receptacle out to some headers. I took the plug out to some headers, included some grounds. I used that power connector. I added just a 10 microfarad surface mount cap there, a couple of pin headers for power, and then just a power LED if I want it. I laid that out into this PCB, which then looks something like this when it's all said and done. And so my power will connect in here. I'm going to be able to daisy chain it to the next board just with a little jumper here if I want to do that. And then of course I've got my receptacle, I got my plug, I got my headers, and then the capacitor, resistor, and LED for power, but nothing exciting there. And I think that all should come out okay. Again, the couple of issues that I have outstanding is why are these coming in as all black? If anybody has an easy solution to that, let me know. I did find, that this 3D model for this component was actually not correct according to the data sheet at least, and me actually physically connecting or physically measuring and laying out on paper, taking the physical component, putting it out on paper, that the way I have it set up is actually correct and the 3D model is incorrect. But long video, so if you've been hanging on here, thanks. If you've got any feedback, suggestions on any of this, let me know. Appreciate it. Thanks.